Imagine standing on the shore 2 evenings in a row, watching the sun dip below the horizon. The scene looks familiar, warm, oranges and purples. As the old saying goes, you never see the same sunset twice, hinting that even repeated experiences. It reflects a profound truth about change at every level of reality in nature, in our brains, in our memories. Ancient philosophers like Heraclitus recognized that everything flows. We'll trace this idea through 5 lenses: philosophy, brain science, and the changing self-hand. Discover how embracing impermanence can transform everyday life. Heraclitus, 535–475 BC, stands out among the pre-Socratic philosophers. Poetic fragments, he challenged the prevailing view exemplified by Parmenides. Instead, Heraclitus argued that all things emerge through the tension of opposites and dissolve back into one another in an endless cycle unity of opposites. He observed that the straight and the crooked path of the fuller's comb is one and the same. His most famous line, rendered variously as "you cannot step into the same river twice," or "on those who step into the same rivers," and the ever-changing self who wades in it. Though only a handful of his writings survive, they consistently emphasize that flux, Greek panterai, everything flows, is not a quirk, but the universe. A new sun every day. Another fragment deepens this insight by extending it beyond rivers to the heavens. The sun is new each day. On the surface, this seems metaphorical, yet even the sun, a seemingly eternal star, is in constant process. It travels through the galaxy, altering its position relative to Earth, and the interstellar environment, our atmosphere's composition and particulate content shift daily, changing how sunlight scatters to create dawn and dusk colors. Thus, even the cosmic backdrop of your sunset is never identical from one evening to the next. Processes, not things. Heraclitus urged us to reconceive reality not as a collection of static things. A mountain, though it appears permanent in a human lifetime, is slowly eroded by wind, rain, and chemical weathering. It may rise anew through tectonic uplift. A forest grows, burns, regenerates. Even minerals like salt precipitate and dissolve in watery environment, shifting the geochemistry of entire lakes. In this worldview, being is an illusion. Reality is always becoming. What seems fixed is simply a phase in an unending process of transformation. Impermanence of self. Heraclitus' doctrine applies equally to our inner lives, from Stoicism to Buddhism. Philosophical traditions. Stoicism, Marcus Aurelius, wrote that our minds are like a field of changing perceptions. Buddhism's Anicca, as one of the 3 marks of existence. Lee teaches that all conditioned phenomena, bodies, thoughts, emotions, are transient and ever-changing. Clinging to them as permanent is a root of dissatisfaction. Modern biology affirms this. Roughly 1% of our cells are replaced each day, so that over a few months, neurologically, our brains reorganize continually via neuroplasticity each time we learn, recall, or feel psychologically. Every experience. In the light of Heraclitus' insight, the self is not a static identity, but a continuously renewing process, a constantly rewiring organ. At its core, neuroplasticity refers to the brain's remarkable capacity to reshape its own structure and function in response to experience, far from being a static hardware device. The brain behaves more like a living ecosystem, continually pruning, strengthening, and forging new connections between its 100 billion neurons. 2 key processes underlie this adaptability. 1. Synaptic plasticity. Long-term potentiation, LTP, repeated or high-frequency stimulation of a synapse makes it easier for the same neurons. In effect, cells that fire together wire together. Long-term depression, LTD. Conversely, lack of coordinated activity can weaken a synaptic connection, allowing the brain to discard rarely used pathways and conserve resources. 2. Structural plasticity. Dendritic spine, remodeling individual neurons, extend or retract tiny protrusions, spines on their dendrites to form new synapses or dismantle old ones. Neurogenesis in certain brain regions, most notably the hippocampus. These mechanisms ensure that the brain is never frozen in a single configuration. Instead, it dynamically reshapes itself in real time to encode every lesson, sensation, and emotion. Learning and rewiring in action. One first piano lesson. On your very first attempt at playing a simple melody, your motor cortex and cerebellum scramble to coordinate finger movements initially. This network is inefficient. Your fingers stumble, timing is off, and the sound is hesitant. At the synaptic level, LTP is just beginning to strengthen the few neuronal connections that manage the correct sequence. To repeat tomorrow. When you pick up the piano bench again, those nascent connections give you a slight edge. Yet the brain doesn't simply replay yesterday's pattern. Your correct, mistimed notes adjust force. LTD may weaken off-target pathways, while further LTP bolsters the more accurate one. 3. Long-term practice. Over weeks and months, a precisely tuned network emerges not only in motor regions. Each practice session rewires the network subtly, influenced by factors like your current mood, physical fatigue, or even the acoustics of the room you're in. If you miss a week's practice, some synaptic strength decades return to the bench. 4. Beyond music. Other examples. Language learning adults struggling with a foreign accent reveal plastic changes in auditory cortex and vocal motor areas. Juggling studies beginners show gray matter increases in visual motion brain regions within weeks of juggling practice. These gains recede if practice stops, demonstrating both growth and pruning. Experimental evidence rat maze study. In a landmark experiment, researchers recorded from hundreds of neurons in the prefrontal cortex of rats running a maze, repeatedly no two runs. The lead author summarized, as far as the brain is concerned, every experience is unique, no matter how similar it is to an earlier one. London taxi drivers, a famous MRI study, found that veteran London cab drivers, this growth correlates with years of navigating the city's labyrinthine streets, and shrinks again if they leave the profession, underscoring ongoing structural plasticity stroke recovery. After a stroke damages one motor region, adjacent areas can reorganize to take over lost functions. Intensive rehabilitation harnesses neuroplasticity, guiding surviving circuits to rewire and restore movement capabilities. These and many other studies illustrate that the brain refuses to remain static, treating each repetition as an opportunity to refine, adapt. Why novelty matters. 1. Adaptive vigilance. If the brain simply replayed a stored pattern every time you experienced a familiar event, it might miss small but critical changes, subtle shift in cloud formation, signaling an incoming storm, or a fleeting change in a loved one's expression. 2. Prediction and learning. Contemporary theories liken the brain to a Bayesian predictor, constantly comparing incoming sensory data with stored expectations. When reality deviates, a prediction error signal fires. Labeling each event as novel ensures the brain stays alert and learns from every mismatch. 3. Emotional salience. Novelty itself can be rewarding. The neurotransmitter dopamine surges in response to unexpected stimuli, reinforcing exploratory behavior. This system encourages us to seek out and encode new information rather than rely on stale patterns. 4. Avoiding rigidity. A too rigid brain risks overfitting to past data, becoming inflexible in changing circumstances. The brain maintains a balance between stability and change, ensuring resilience in a dynamic world. In sum, neuroplasticity transforms every learning moment, whether your first piano lesson or a daily commute, into a unique event. Your brain's wiring never simply replays the past, it continuously rewires, ensuring that no two experiences. The brain's fresh eyes principle. Predictive coding. The brain as a Bayesian inference machine. Contemporary neuroscience. Guess model of the world, then compares incoming sensory signals against that model. When there is a discrepancy, a prediction error, the brain updates its model to reduce future errors. This predictive coding framework inverts the classical bottom-up view of perception, rather than passively building up a picture from raw sensations. Top-down predictions constrain interpretation, and only unpredicted inputs propagate upward as errors. Even infants exhibit this when an expected visual stimulus is omitted. their occipital cortex still respond. Driven prediction error, signal at work, prediction error signals, and precision-weighted attention. Not all prediction errors are equally salient. According to a leading extension of predictive coding, the brain assigns a precision weight akin to statistical confidence of each error signal. Weighting mechanism underlies attention unexpected, inputs deemed reliable elicit enhanced neural responses. Carl Friston and colleagues propose that neuromodulatory systems, e.g., cholinergic and noradrenergic pathways, dynamically tuning cortical circuits to emphasize relevant prediction errors and suppress irrelevant noise neural signatures. Mismatch negativity in vision and hearing, a striking electrophysiological signature of prediction error detection, is the mismatch negativity MMN in EEG recording. In the auditory MMN, a rare deviant tone amid a stream of identical standard tones. The visual MMN BVM arises when an infrequent alteration, e.g., a shape or color change, violates an established visual regularity, often without conscious awareness. These MM components confirm that the brain continuously flags small deviations from predicted sensory pattern, embodying the fresh eyes principle at the neural level sunset through this lens. One no clouds yesterday, some today. The presence of novel cloud wisps violates yesterday's prediction of clear sky. Even slight textural differences generate localized prediction errors in visual cortex. Two same orange hue, different brightness. Minor shifts in luminance or color saturation adjust precision weights. A brighter or dimmer glow than expected draws attention. Three new emotional contexts. Predictive models incorporate not just sensory patterns, but also affective states. Watching solo, when reality mismatches that affective prediction, the resulting error signal can make the identical color palette feel poignant or tranquil. The brain ensures we remain attuned to subtle environmental shifts, be it in the sky's texture, hue, or our own mood. Déjà vu revisited ironically. Predictive coding can also produce déjà vu, the uncanny sense of familiarity. In a truly new situation, researchers suggest that when a current scene almost matches an internal model falling just short on low-level sensory details. In one study using virtual reality mazes, participants experiencing déjà vu felt confident predicting the next turn, even though they were no better than chance. Highlighting can arise from a mismatch between predicted and actual sensory inputs. This predictive coding account of perception shows why no two sunsets. Each encounter generates its own pattern of prediction errors, guaranteeing a fresh perspective every time. The mutable tapestry of memory. Memory as reconstruction rather than serving as a perfect recording device. Pioneering psychologist Sir Frederick Bartlett demonstrated this in his 1932 War of the Ghosts experiment. With each retelling, they systematically omitted, simplified, or rationalized details to fit their own cultural schemas. Line modern schema theory builds on Bartlett, showing that scripts, stereotypes, and prior knowledge fill in memory gaps, producing memories that feel coherent but often diverge from the original event. Evidence from the laboratory studies confirm that each act of recall not only accesses a memory but alters it. A Northwest University team led by Donna Bridge had participants view short videos and later asked them to recall details under different contexts. Functional imaging revealed that reactivating a memory temporarily destabilizes its neural trace. Every time you remember an event, your brain networks change in ways that can alter the later recall of the event. It already carries edits from every intermediate recollection, mixing the original perceptual details. Contextual drift memories also drift based on the emotional and environmental context. At recall, classic studies, people in a happy mood more readily recall positive events. State-dependent memory shows that recall is better when the internal state, e.g., stress level, pharmacological condition, matches that of encoding. Applying this to our sunset, if you later remember it while nostalgic, if you recall it during a stressful period, that reconstructed memory may feel tense or foreboding over weeks and months. These small emotional tints accumulate, so your recollection no longer matches the exact colors and feelings you first experienced. Adaptive purpose, although reconstructive and error-prone, such memory malleability serves adaptive functions. Harvard psychologist Daniel Schachter's processes argues that memory's flexibility enables us to imagine the future, solve problems, and plan by recombining fragments of past with occasional distortion. In everyday life, the goal of memory isn't perfect fidelity, but usefulness, integrating lessons learned. By dynamically reshaping memories, the brain ensures that your recollections inform present decisions and prepare you for novel challenges. Turning. Researchers estimate that roughly 1% of all our cells are replaced every single day, about 330 billion cells, 30 trillion new cells, virtually reconstituting itself. Blood cell. Red and white blood cells turn over on timescales from days neutrophils to months. Red blood cells. Epithelial cells, lining the intestine live mere days before being sloughed off, and renewed skin cells. The epidermis constantly sheds and replaces cells over weeks. Bone and muscle. Slower turnover tissues like bone and skeletal muscle regenerate over years. Even though some organs, e.g. neurons, in much of the cortex are long-lived, the enormous turnover elsewhere means the mass and composition of your body is never static. Neural renewal. While many brain cells persist for decades, the adult hippocampus, a region critical for memory, continues to generate new neurons in human. Carbon dating studies of DNA have estimated a median turnover of about 175% per year, corresponding to 700 new hippocampal neurons. Atomic fallout, dating a landmark 2013 study, used 14C from Cold War nuclear testing to show that human hippocampi incorporate new neurons throughout life, linking renewal to learning and mood regulation. Functional impact. Adult neurogenesis is thought to support pattern separation, distinguishing similar memories and resilience to stress. Whether by cell turnover in the periphery or by neurogenesis centrally, your brain's hardware is always being remodeled. Evolving perspectives beyond physical renewal, your mind and outlook shift continuously. One, knowledge and belief. Every article you read, every conversation you have, subtly updates your internal model of the world. Educational psychology. 2, emotions and hormone. Your affective state biases perception. Research on cortisol reveals that acute stress, as stress hormones fluctuate hourly, your emotional lens tilts your experience of even identical sight. 3, social context. Who you're with and the surrounding environment modulate perception via the amygdala's salience network. Social neuroscience. That identical faces or scenes evoke different neural responses. Moreover, social buffering studies show that simply seeing a familiar companion can dampen cortisol responses to stress. Taken together, your knowledge base, emotional state, and social surroundings continuously reshape how you perceive and thus who you are in any given moment. Identity as an ongoing narrative. Philosopher Alan Watts captured this fluid self in a single line. Modern psychology agrees identity is not a fixed snapshot. Researchers in narrative identity propose that we weave our experiences into an ever-evolving self-narrative, integrating new events, emotions, and insights. We organize memories and aspirations into chapters: student, parent, professional, that overlap and shift. Self-reinvention. Within moments, we adopt new roles and mindsets, e.g., calming into meditation, gearing up for a test, each requiring rapid neural and psychological adjustments. Thus, not only is the sunset new and your body new, but you, the observer, are perpetually renewed. There is no single fixed you that watches any two sunsets, the same way the importance of noticing change. Autopilot versus awareness. Our brains are to conserve energy by relying on familiar scripts for routine activities. This autopilot mode, linked to the brain's default mode network, lets you carry on tasks efficiently, but also causes long stretches of life to blur together. Research that when people rehearse a habitual event without detecting novelty, they form weak or fused memories. Event model comparison and change detection. Jeff Sachs and colleagues. Event memory retrieval and comparison, EMRC. 1. As you live through an event, your brain builds an event model, a working prediction of upcoming features based on similar past episodes. 2. When actual sensory input matches that model, the experience is treated as routine and encoded shallow. 3. When a feature deviates, a coffee mug is blue instead of red, or a piece of furniture shifted, the resulting prediction error triggers a cascade, updating both the old model and the memory of the new event. In laboratory experiments, participants watched 2 days of videos depicting routine tasks. Those who detected the subtle changes between day 1 and day 2, e.g., a different object placed on the table, later remembered each day clearly. By contrast, participants who missed the changes had poor recall and often conflated events from both days. Practical techniques for cultivating change awareness. You don't need a lab to sharpen your change detection skills. 1. Mindfulness scanning. Oh, what it is bringing careful, non-judgmental attention to present moment experience. Oh, why it works. Mindfulness heightens sensory precision and reduces habitual filtering. Meta-analyses show mindfulness training improves attention, concentration, and openness to new details. During a routine, e.g., morning tea, pause and note one fresh detail, steam swirling in a unique pattern, an unexpected aroma. Note. 2. One-line journaling. Oh, what it is writing a single sentence each evening about something different you noticed that day. Oh, why it works. Positive psychology research on gratitude journaling and reflective writing shows that even brief notes enhance memory, specificity, and emotional regulation, preventing days from merging into one another. Oh, how to practice. Keep a small notebook by your bed. Each night, jot one new observation, a changed cloud shape, a fresh thought that arose, or a minor shift in routine. 3. Photo a day. Oh, what it is taking one photograph of anything that felt novel each day. Oh, why it works. Visual diaries, externalized memory cues. Research on novelty and well-being finds that actively seeking new experiences. Use your smartphone to snap one quick shot daily. No artistic skill required, focusing on what felt different, unusual, or simply beautiful in that moment. By intentionally noticing small changes, cloud wisps, mug colors. This moment matters. In doing so, you enlist your own cognitive machinery to encode each event as a unique memory, transforming routine repetition into a tapestry of distinct, meaningful experience. Embracing the richness of mundane life. Gratitude and presence. Cultivating gratitude turns routine into revelation when you recognize that today's sunset is an entirely new event, never before seen, never to recur. You naturally feel a surge of appreciation. Empirical studies show that gratitude interventions such as listing things you're thankful for reliably increase positive affect, life satisfaction, and physical health. Measures like sleep quality and immune function, even brief practices. Comfort in impermanence, knowing that this too shall pass, isn't just a platitude but a cognitive tool, can soothe distress. Research on temporal distancing demonstrates future-oriented perspective on current stressors. They experience significantly less emotional distress, mediated by focusing on impermanence. By framing both joys and hardships as fleeting, we gain emotional resilience. Peaks feel richer and troughs less overwhelming. Psychological payoff of novelty. Our brains reward us for noticing the new dopamine neurons fire in response to novel stimuli, reinforcing exploratory behavior and enhancing mood. The hedonic adaptation prevention HAP model further shows that introducing small surprises or changes into daily routines, unexpectedness, act as buffers against boredom and hedonic fading. Thus, every day, or when we allow ourselves to see the ordinary as extraordinary, life gains depth. Ralph Waldo Emerson. To the attentive eye, each moment of the year has its own beauty, and in the same field, it beholds, every hour, a picture which was never seen before, and which shall never be seen again. By adopting that attentive eye, in combining gratitude, an embrace of impermanence, a touch of novelty, we transform the repetitive into the remarkable, revealing that the richness of life truly lies in noticing the ever-changing tapestry of ordinary moments. Conclude. A new sunset, a new self, as our journey through ancient wisdom and modern science shows, to the neuroplastic brain that rewires with every thought and sensation, to memories, one synthesis of insights. Philosophical Flux, Heraclitus, taught that reality is a process rivers. Neuroscientific Novelty, Predictive coding, and Neuroplasticity ensure that your brain greets each repetition not with a replay, but with a recalibration, stamping novelty on every sunrise and routine action. Memory's malleability recall reshapes the past, so yesterday's sunset exists today only as a living, evolving tapestry woven by each act of remembrance. Biological renewal, your cells, too, from autopilot to attentive living. Armed with this understanding, we are invited to leave autopilot behind when you notice. Spot the unique swirl of clouds, or the new thought that arises with coffee save. Take a moment to feel gratitude that you witness an event that never happened before or appreciate. Embrace impermanence by knowing both joys and trials are fleeting, that this too shall pass carries literal truth. 3. Everyday practice, extraordinary life. Transform small rituals into acts of mindful discovery. Journal a single fresh detail. 4. Honoring uniqueness. In honoring each moment's unrepeatable nature, we honor life itself. The world is a river of moments. By waking to this flow, we embrace a deeper engagement with reality. Each sunset becomes not a mere ending of a day, but a singular, irreplaceable experience. So the next time you see the sun dip below the horizon, pause and remember this sunset, like you, will never come again. In that recognition lies both wonder and wisdom, and the fullest expression of living.